Welcome, Hornets. In this video, we're going to be talking about particle motion, specifically talking about speed. We'll be talking about whether we're moving left or right. We'll be talking about whether speed is increasing, decreasing, moving towards or away from the origin. We'll also be talking a little bit about our connections between the first derivative, the second derivative, and how they are represented on this with acceleration and velocity and position. So we are looking at the graph of v of t on the interval. It is an open interval from 0 to b, and we have the points C, A, D that are in between 0 and b in the order presented. Now, I'd also like to point out that the derivative of v, we are going to be calling a of t, where a of t is the acceleration, and this is of the primary position function s of t. And I'm just going to make sure that we're very clear. S prime of t is v of t. So just giving a few parameters about what we're talking about. Now, the first thing I want to point out is that velocity is the absolute value, or speed is the absolute value of velocity. And we're talking about something more like a vector. It has a direction, it has a magnitude. So when we talk about a maximum speed, we can be talking about a speed that is moving left, or we could talk about a speed moving right, or up or down, depending upon the axis that we're moving along. So here we're talking about velocity, and therefore velocity is equal to 0. And because we're talking about an open interval that's the derivative of a position function, we know the endpoints aren't going to be evaluated. So we have our one position where whatever's happening, our particle is at rest. Now, by convention, we have two directions. We have a positive velocity, and a positive velocity will denote movement right. And a negative velocity is talking about movement left. Now you'll notice there's going to be a lot of little facts that you're going to have to remember as you do this. So try to keep them straight. What you're talking about and how they relate to each other. So if we have a particle that is moving to the right and stops and then moves to the left, it only makes sense that it decelerates as it moves towards its rest position and then accelerates afterward. Now, this is where we start to talk about the speed and acceleration. For example, on this increasing interval, we have our acceleration positive. So we have a positive acceleration on an increasing interval of velocity. Then we have a decreasing interval. And you'll notice this decreasing interval is going to be where our acceleration is negative. Now, we've talked about this in our other graph where we've talked about it as the second derivative. So if we're talking about the first derivative, an increasing first derivative is a positive second derivative, and a decreasing first derivative is a negative second derivative. Now, right up here, we are at our maximum speed to the right. This is also our maximum velocity. So notice we have velocity graph, and this is a maxima on that velocity graph. So lo and behold, it's called a maximum velocity. Well, since we have an absolute value of velocity as speed, this is where we have a maximum speed. And right here we have another maximum speed. This is now our relative minima, but it's going to be a maximum speed to the left. Now you'll notice if I have the particle at rest right here, and I'm at a maximum speed, or I have a maximum speed here, and then the particle is at rest, then something has to be happening, and it's called a decreasing speed. So on this decreasing interval, I have a decreasing speed. And right here where I have this increasing interval, I can now call it increasing speed. Now, what's going on? Well, let's just look from here to be at rest and then moving left to a maximum speed to the left. I once again have to have an increasing speed. But you'll notice now my acceleration, still on a decreasing interval, is less than zero. But it's with a velocity that's less than zero. Notice right here, we have to have a decreasing speed and we have acceleration that's now greater than zero on an increasing interval. So be aware that what we're looking at is similar signs. In fact, the same signs for velocity and acceleration when speed is increasing. And we have opposite signs when speed and of acceleration and velocity when the speed is decreasing. That happens here again, and it happens here again. So we can now start making some generalizations about speed increasing. Speed increases when velocity v of t and acceleration a of t have the same sign. Furthermore, when they have opposite signs, the speed is going to decrease. So speed decreases when velocity and acceleration have opposite signs. So here's the first part of my video. In the next part, we're going to be talking about toward and away from the origin. So just to recap, we have movement to the right is when velocity is positive. Movement to the left is when velocity is negative. A particle is at rest when velocity is equal to zero. We have speed is the absolute value of velocity and is therefore being turned into something similar to a vector, which has a magnitude and a direction. Therefore, we have a maximum speed right when we have a relative maxima, and we have a maximum speed left when we have a relative minima. We have speed increasing when velocity and acceleration have the same sign, and we have speed decreasing when velocity and acceleration have opposite signs. Thank you very much, Hornets. I hope this has helped, and I hope that if you need further assistance with this, you can listen again. All right. Take care. Be well. Be safe.